Many programs have to deal with text processing, and a lot of text processing is defined already inside the string class, which we will cover later. So you can, for example, search for fragments of text, replaced fragments of text. You can do some other processing within the text, insert fragments of text. So here, however, part of the C library, we have these character classification functions, which are very helpful to when you work with individual characters. These functions allow you to decide whether a character is an alphabetic, uppercase, lowercase, digit, and other types of character classification routines. You can actually look for documentation for CC type, these character classification routines coming from the CC type, and you can also use to uppercase and to lowercase conversions to convert to uppercase and lowercase. So this is an example of basically just defining a character, setting it equal to uppercase A character, and then checking whether it's an alphabetical character. As you can see, these functions return an integer result, and if the result is non-zero, it means that the check succeeded. And if it's 0, then the answer is that no, it's not an alphabetical character. So we could just probably just, I'll encourage you to copy and paste this example into your own source file and build a few of these and try to change this to a space or to a digit like 0, 1, 2, 3, 4, 5 and check and just basically check these functions just to see what they return and print as a result. So these are very useful functions to determine the type of character that you're dealing with. Now we've seen the use of function parameters where we're calling ping and pong. So I already told you how the stack mechanism is using passing parameters to initialize these parameters. And here's just an example of using a function named square. And this function named square is taking a value, an integer value. So we take this value 5. So apparently we make a copy of this value and we pass this value to a function. So its own parameter x is going to be initialized with this value right here, and we multiply it by itself, which is an idea of computing the square value, and obviously the result should be returned as 25. This program here, if I want to download it, actually animates the passing of a parameter to a function such as square. So let's take a quick look at this animation just to see what it shows. So I just downloaded this and I'm just going to say open. Of course, an operating system is trying to protect me against running a program that I just downloaded, so I'm just going to, it really doesn't give me a lot of options, so I'm just going to say don't run, and instead go to my download view. So it's in my downloads area. So I'll just go to here and right click on properties of this program, and in the general section right here it says that the file came from another computer, so you can unblock it. So just click unblock and apply this option, and let's see if now I can run it. Okay, so now it starts. So we have this little animation here that says square, right? So this is an idea of a function square, and the main function that we set the value local variable here to 5, then we call square, and of course so the square is invoked, it does its own computation, we return back, and the result becomes 25. Right, and another animation here is showing us the stack frames that we discussed in our series of presentations regarding the ping pong game. So here we have a declaration of a square, and so the function prototype tells the compiler function name, return type, as well as the order and type of parameters. So the square using x as an input parameter. The main function, of course, right here is occupying certain space in our text segment, and it has the code integer I, and then you're calling a square. So when we enter our main function, on the program stack is actually return address back to the operating system. So then as we click the opening brace right here, the main function stack frame is constructed. So it has two variables I and P, and initially they're set to question marks, which means that there are in uninitialized memory, and so we have our main frame right here being constructed. So now X is initialized with 5. So the initializer basically gives the variable the actual name, value, right? So X becomes 5. Then we call square. So as we call square, recall how we discussed that the local variable is passed into the memory just outside of the stack frame of the main function, and it's look like an orphan value sitting right here in our program stack memory segment. But then as we proceed to call this function, okay, so right here, so the function organizes its own stack frame, and the return value back to the main function is also placed on the stack. But then as the opening of the square bracket is executing, the x input parameter, x underscore, it's the name of the input variable here, is getting placed right here where this temporary value 5 was placed. And of course we continue executing it, so we're computing the result 5 times 5, which is 25, and the value that this function is going to return is going to be temporarily preserved inside the CPU register EAX. EAX stands for Extended Accumulator Register on Intel platform on which I'm running this demonstration program. And so this is where the return value is preserved. And then we return, but remember the first that we executing the closing brace of the square function, right? So the square function now complete. So as part of this execution, you see this animation that the stack frame is gone, and the CPU register gives our resulting variable P right here in the main function. It gives the result 25. So this is just an animation of the stack frame behavior, and then as we get out of this function and get out of our program, all stack frames are gone, and we're now returning back to the operating system. So it's just a quick demonstration of some of this work. You can try to run this animation on your own, click around and just observe what happens, how this program stack area behaves. This really animates the actual memory used by this demo program when we're making these function calls. So this is an actual demonstration of what happens in memory of this demonstration program.